That is the sound that is often associated with an explosion. This presentation will cover organic chemistry, redox reactions, entropy, reaction rates, chemical changes, and the collision theory. But first, I must bore you with background information. An explosive is any substance that contains a large amount of potential energy that will result in the sudden increase in volume and energy in the surrounding system, and is usually accompanied in the production of sound, heat, and light. Explosives can be classified by the way they detonate, which is either by deflagration and detonation. For deflagration, heat is transferred to thermally conduct the explosive material, which will activate it and create an explosion. It is called a low explosive because its impact is less powerful than detonation.
Detonation uses a shockwave traveling faster than the speed of sound to transverse through the explosive, which will cause it to decompose and activate. Since detonation is capable of creating a very powerful explosive, it is called a high explosive.
Organic chemistry! Thank you, it's time for my epic part of the presentation, which will make Johnny's presentation look bad. Many explosives contain organic functional groups such as NO2, ONO2, and NHNO2. These groups will cause a stronger explosive depending on the functional group used. This will change the magnitude as well as other features of the explosive such as color. Functional groups including nitrate isomers are common in explosives. These explosives compose of covalent bonds between carbon and the nitrogen atom of the functional group. The potency increases with more impurities in addition to which functional groups are used. Examples of these explosives containing nitrogen functional groups are TNT and nitrobenzene. These are frequently used in mining and other activities. However, other functional groups such as organic azides are also found. These explosive azides are highly susceptible to friction and impact and thus are highly reactive explosives. Compared with inorganic azides, they require much less activation energy. Now back to my boring partner, Johnny. Ho 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 ho!
Sorry folks, please don't close this browser to stop watching this video just because Wayne is boring you. Explosions can be related to a chemistry unit our chemistry course covered recently, oxidation and reduction reactions. The gain and loss of electrons occurs in all chemical reactions, but for explosion, it occurs at a fast and alarming rate that releases energy as a result. An example of a redox reaction in explosives would include the decomposition of nitroglycerin. Nitroglycerin is a compound that consists of 3 nitrate groups bounded to a hydrocarbon. Nitrates are a powerful oxidizing agent since they gain electrons during the reaction as shown. Kaboom! One of the reasons that nitroglycerin is highly explosive is because nitrates are a powerful oxidizing agent, which means that the oxygen molecules in the nitrates can be used for fuel instead of oxygen in the atmosphere during the combustion reaction.
Sorry, I didn't catch any of that. I guess I fell asleep from your boring presentation. During an exothermic reaction, energy is spread out and becomes more dispersed. When explosive materials are activated, the enthalpy increases as energy is dispersed around the surrounding area. Enthalpy can be quantified as the measure of energy released during the chemical process. This energy is non-regainable as opposed to enthalpy. This is dissipated mainly as heat and contributes to the randomness in the universe. The second law of thermodynamics states the enthalpy of the universe increases with any change that occurs. Mathematically, delta S universe is greater than 0. During an exothermic reaction, energy is spread out and becomes more dispersed. When explosive materials are activated, the enthalpy increases as energy is dispersed around the surrounding area. Enthalpy can be quantified as the measure of energy released during the chemical process. Enthalpy is also useful in conjunction with enthalpy change to determine whether the reaction occurs spontaneously. The equation used is delta G equals delta H minus T delta S. Since the enthalpy change of the reaction is negative and enthalpy is positive, Therefore, any explosion is a spontaneous reaction at any temperature, adding to its sensitivity levels. This energy is non-regainable as opposed to entropy. This is dissipated mainly as heat and contributes to the randomness in the universe. The second law of thermodynamics states the entropy of the universe increases with any change that occurs. Mathematically, delta S universe is greater than 0.
Sorry, Wayne is pretty boring. I hope you're awake to listen to my part of the presentation. The reaction rate represents the speed of a chemical reaction. An explosive reaction often has a high reaction rate value due to the high rate of decomposition of the reactants when it is activated. The equation used to calculate the reaction rate is the change in quantity of the reactants divided by the change in time. Another equation, the rate law, can be used to calculate the reaction rate. The values A and B represent the reactants if there are two in the reaction. The letters C and D are the rate law exponents, which is relative to the rate of decomposition of the reactants. The K value is constant and increases along with temperature. Since the K value of the rate law is directly correlated with temperature, it can be said that an explosive reaction rate increases along with temperature.
Chemical changes. For a presentation about such an awesome topic, I can't believe you were able to make it so boring. Some people. Explosives possess a high amount of chemical energy in their bonds. As an explosive combusts, their bonds are broken and then reformed. Since the reaction requires more energy to form bonds than to break them, it is an exothermic reaction. Enthalpy change is one method of quantifying the energy lost or gained. It defines the total change in internal energy in a reaction. A negative value indicates an exothermic reaction. The main chemical change during the explosion is the conversion of potential energy stored in the bonds of the compound to kinetic energy. The products of the explosion are always in a gaseous state. Gaseous compounds form highly stable compounds such as carbon monoxide and carbon dioxide. These compounds have high bond energy ranging around 1000 kilojoules. However, the stored potential energy is not high compared with other fossil fuels. It is a high rate of energy release and detonation velocity which accounts for their deadly potency. The enthalpy change of this reaction depends on environmental conditions such as pressure. As heat is released in this reaction, the gas expands quickly and heat and light are released.
Sorry, we might have drained the life out of this presentation, but I can assure you that the finale will be epic. The collision theory and surface area explains why some explosives, such as gunpowder, have a high reaction rate. For a reaction to be successful, the reacting molecules must collide with one another. This breaks the bonds between the reactants and forms the bonds of the products. The activation energy is the minimum amount of energy required for a reaction to go forward. The diagram depicted shows that as more energy is placed in the system, the collision becomes more effective and the reaction goes forward. While the activated complex is formed and the explosion reaction will release energy in the process. Therefore, a higher activation energy rate will increase the collisions and reaction rate. This will create a bigger explosion. Pressure affects the collision rate if the products are in their gaseous states, since increased pressure would cause more collisions between the reactants. As shown in the diagram, there is a smaller volume in the pump that is compressed more. This gives the reactants of higher collision rates as more reactants collide with one another in the smaller pump. Therefore, it can be concluded that a higher pressure rate would increase the rate of the explosion. A greater surface area would allow more collisions to occur since there are more space for the reaction to occur. This would increase the likelihood of the chemical reactions to occur and increase the explosive's decomposition rate. As depicted by the diagram, the larger surface area allows more reactants to collide with each other, whereas the smaller surface area does not. A larger surface area will allow more collisions to occur between both reactants.
Applications. Now here's the final part of the presentation, which will cover their applications. Explosives are not only used as weapons, but are also used for mining, construction, bombs, bigger bombs, and most importantly, even bigger bombs! Ha 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 ha! Explosives can be divided into 3 categories depending on their sensitivity. Not surprisingly, they are primary, secondary, and tertiary explosives. Primary is the most sensitive to stimuli, and low amounts of energy is needed for the reaction to begin. The main use of these explosives is to trigger secondary explosives. Another important use is in blasting caps, which transfer shock signals. Examples include lead and sodium azide. Secondary explosives are less sensitive and still require considerably more energy for detonation. Since they require large amounts of energy for detonation, they are safer for use and storage, and thus explosion can be controlled more efficiently. Compared with primary explosives, they are used in more applications. One example is that they are used in large quantities for an explosive train. Examples include TNT and RDX. Tertiary explosives are also referred to as blasting agents. They are very insensitive and require large amounts of secondary explosives to activate them. However, they are important for mining and construction, and unfortunately also for terrorism. That concludes our presentation. We will not be taking any questions at this time, and all YouTube comments will be ignored. Ha 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 ha.